If a rocket is fired vertically into the air with a speed of 240 feet per second, its height at a time t seconds is given by h equals negative 16t squared plus 240t. At what times will the rocket be the following number of feet above the ground? In A, it says that the rocket will be 800 feet after so many seconds. Well, h stands for our height, so let's go ahead and plug in 800 in place of h, and we continue with the rest of the equation. So at this point, all we need to do is rearrange this equation and solve for t. So what I'm going to do is I'm going to move the 800 over, and I know that's going to leave a negative in front of my 16t squared, but I'll show you what we can do to deal with that. So now I have 0 equals negative 16t squared plus 240t minus 800. Well, not only do I want to factor out the negative, but I'd also like to factor out as large a number as I can that can go into this equation. So what I'm going to do is I'm going to start by seeing, can I divide this by, say, 16? And I can. So I'm going to factor out a negative 16. So for the first term, that's going to leave me with a positive t squared. For the second term, by taking out a negative, that's going to make it a minus, and 240 divided by 16 is 15, so 15t. Now, dividing negative 16 into negative 800 gives me positive 50. So now this is going to be much easier for us to deal with, and again, I can still use quadratic, or I can simply factor that one. The 16 isn't going to matter because there's no variable in front for us to worry about. So I technically could simply divide both sides by negative 16 and get rid of it. So I'm going to go ahead and factor this out. So again, by factoring, I'm making a multiplication problem. So t squared, so t times t in the front. Now I'm looking at 50, and I'm looking at, since it's a positive 50, two numbers who multiply to be 50 that add to be 15. So we'll go with 5 and 10. Now, since it's a negative 15, and we know both of these have to be a negative number to be a positive, so t minus 5 and t minus 10 are my factoring. I'm going to set each of these equal to 0. So I take t minus 5 equals 0, t minus 10 equals 0. So it's possible that at 5 seconds and at 10 seconds, that's when the rocket will be at 800 feet. Which means that this is going to be when the rocket's going up, and maybe when the rocket's coming down, it'll be at 10 seconds. So these two different answers are basically telling you that as the target goes off, the rocket goes off, it's going up, and at 5 seconds it's at 800 feet, and apparently it's going to come back down again and be at 800 feet in 10 seconds. Now let's take a look at part B. The rocket will be 704 feet high after so many seconds. Again, they're giving us the height of 704. So I'm going to replace the height with 704, and this will equal negative 16t squared plus 240t. Same thing we did before. We need to get it all over to one side so that one side equals 0. So I will simply subtract 704 from both sides. So I now have 0 is equal to negative 16t squared plus 240t minus 704. Now I want to find the greatest common factor again. I'm going to start with 16 and see if I can pull 16 out of each of these numbers. So we're going to factor again the negative 16. so that my t squared becomes positive. So 240 divided by 16 is still going to be 15t, but now my positive 240 divided by negative becomes minus 15t. And now I have negative 704 divided by negative 16 is going to give me a positive 44. And as before, I'm going to focus on the trinomial in order to calculate the answers. Since this number out front does not have a variable, it does not come into play. So let's go ahead and let's do the factoring. So t squared again is t times t. So now I need two numbers who multiply to be 44, who add to be 15, because again, I have a plus sign at the end. And since they're going to be the same sign and the middle term is minus, I know they're both going to be minus. So if I'm looking at 44 and has to add to 15, I think 4 times 11 will work because 4 plus 11 is 15. So now I'm going to take each of those and set them equal to 0. So t minus 4 is equal to 0. T minus 11 is equal to 0. So the time here could possibly be 4 seconds, and the time here could be 11 seconds. And again, the reason we have two different times is the rocket goes up, and it hits 704 feet at 4 seconds, and then comes back down, hitting 704 feet at 11 seconds, so a little bit later. Now let's work on part C. How long will the rocket be in the air? Hint, how high is it when it hits the ground? Because remember, the rocket is going to go up and come back down. So it'll be in the air until it hits the ground over here. So clearly, the height on the ground is 0. So we have 0 equals negative 16t squared plus 240. And I'm going to go ahead. Now notice, since this is 16t squared plus 240t, I don't really need to do any trinomial factoring, but I can do greatest common factor. So let's go ahead and pull out the negative 16, but this time we're going to pull out the t. So that leaves me with positive t minus, and so we still have the idea, 240 still divided by negative 16 is still 15. So now I have negative 16t times t minus 15. Now this factoring out here matters because there's a variable of t. So negative 16t, we set that equal to 0, and obviously t is going to be 0. We set t minus 15 equal to 0. T is going to equal 15. So the rocket will be in the air for a total of 15 seconds. At 0, that's when it's starting, and we want to know how long it's going to be in the air after it starts, and that's going to be 15 seconds.